Alright, let's go over ethylene. Now, ethylene has a double bond, and a double bond is comprised of a sigma and a pi bond. Now, a sigma bond is basically the overlapping of two hybridized orbitals, and that can be seen in this diagram here, this one here. It's the overlapping of one carbon's sp2 orbital and another carbon's sp2 orbital. Now, for you to have a double bond, and just a double bond, it is very important that you recognize that you absolutely must have an sp2 orbital. If you recall our energy diagram here, right, you are in an sp2, you are making 3 orbitals of equal energy, but are leaving this one p orbital untouched. Now this is very important, because this one p orbital that you do not touch comes back here. And let me just explain the point of views that we're looking at. Over here, we are looking at this from down, like we are above it and we are looking down. These little purple circles here, that is the p orbital. The p orbital is coming up at you and down into the plane. It's a 3-dimensional shape, and as I said in the previous video, sp2 orbitals are within the plane. They are flat, which is shown here. If I drew it from the side, if we looked on it from sideways, you would see, you wouldn't be able to see the sp2 orbitals, but you would be able to see the p orbitals sticking out of the molecule, and that's because the p orbital is in the z plane, which is 3-dimensional. Anyways, on to double bonding. So what pi bonds are basically two p orbitals interacting with one another. Now that's very important to realize, because if we had instead two p orbitals, we'd have a triple bond. Now let's kind of backpedal, or when I say we have a double bond, that means we have two bonds between a molecule, which seems kind of, unnecessary to explain. But see here, we can only have one sigma bond between the two molecules. The other bond, the second bond, therefore comes from the overlapping of the p orbitals, this pi bond. And that's what constitutes a double bond. And I think that's about it there in that department. So yeah, basically run over that. The p orbitals is what creates the pi bond. Now one thing that I want to make sure that you understand is, because we have an sp2, we have a double bond. That means only sp2 orbitals can have a double bond. And why I say that is because you see this lone vacant, not vacant, but these two pi bonds, two p orbitals, they're interacting. If we had an sp hybridization, remember that would mean we're only using one p orbital in hybridization. Then we have two available. We have two available p orbitals for bonding with another molecule, and this creates a triple bond, and you'd have this sort of sigma bond coming out from here. So this was what would make a triple bond, and that's why it's very important to realize that sp2 makes a double bond, sp3 makes a single bond, and sp makes a triple bond. And that's because of how much um, p orbitals we have available for bonding between two molecules. And that's basically it.